Sometimes you're interested in the probability of more than one specific thing happening, and so in this section we're going to talk about how to add probabilities together. These are called compound events when we're interested in more than one thing happening, and specifically we're going to talk about the probability of one thing or another happening. So probability of A or B means either A or B or both. Now before you find a probability for two events, you need to figure out if they're disjoint or mutually exclusive. So this means that they can't happen together at the same time. For example, if you think about a deck of cards, and A is pulling a spade out of the deck and B is pulling a heart. These are mutually exclusive because there aren't any cards that are a spade and a heart at the same time. On the other hand, if you're looking at pulling a spade versus pulling a 3 out of the deck, these are not mutually exclusive because it is possible to pull a card that is a spade and a 3. It would be the 3 of spades. So that would not be mutually exclusive or not disjoint. So in general, if you want to find the probability of A or B, you can find the probability of A and the probability of B and add them together. What you have to be careful of is that you don't double count something. So if A and B are not mutually exclusive, if there's some overlap, then you may be double counting things when you add the probabilities together. So because of that, we say that the addition rule, to find the probability of A or B, you add the two probabilities together, but then if there's any overlap that's in both of them, you need to subtract that out once because you will have counted it twice. So probability of A plus probability of B minus the probability of them both happening, that overlap that got double counted. For example, let's say that I've done a survey and I've asked people coming out of the grocery store what they drive. And so this chart breaks it down, men versus women. Did they say that they drove a car, a truck, or I put vans and SUVs in the same category. So let's say out of this group of people, I want to know, if you randomly select one, what's the probability that this person either drives a truck or a van SUV? So let's take a look at the truck and van SUV categories here. I have 12 people who drive trucks and 9 people who drive vans or SUVs out of a total of 39 people that I surveyed. These categories don't have any overlap, so I'm free to add the 12 and the 9 together. So I did 12 out of 39 plus 9 out of 39, and then that gave me 0.538 or 53.8%. I could have also added the 12 and the 9 together to get 21 and then divided by 39, and I would have gotten the same answer. Okay, so let's go back, same setup. What's the probability, if I randomly choose one of these people, that the person is either a man or drives a car? Either one, I don't care which, I just want one probability for either of those things happening. So I'll focus in on the two categories. I've got the men circled and then the people who drive cars are circled. Here I need to be a little more careful. There's an overlap here. I have 10 men who drive cars. So if I add together the 18 people who drive cars and the 21 people who are men, I've just double counted 10 of those people. So you can see here at the bottom we've got 21 out of 39 for the men, 18 out of 39 for the chance of driving a car, but then I had to subtract out those 10 out of 39 chance of both happening at the same time because that got double counted. So add those together, subtract the 10, you get 0.744 or 74.4%. Another way that you could approach this problem, since we do have all the individual little numbers and not just the totals, is you could just add together the relevant individual numbers and then just make sure that you don't double count anything. So in this case, we could look at the 8 and the 10 that are the cars, and then add on the 8 and the 3 that are the men, and just don't double count the 10. That'll give you 29. 29 out of 39 is 0.744 again. So you can do this either way. In addition to compound events, sometimes we're interested in the complement. The complement is the chance that something does not happen. So, for example, if you're rolling a die, then rolling a 1 would have a complement of not rolling a 1. So the complement of rolling a 1 would be rolling a 2 through 6. Or if we're talking about having a boy versus having a girl, those would be complements because having a boy is the same as not having a girl. So for complements, their probabilities would be opposites. They would add up to 100%. So if you have a 30% chance of rain, then that means there's a 70% chance that it won't rain. So these two complements would always add up to 100%. That means if you know one of them, you can subtract it from 100% to get the other. When we're working in decimals, we'll use a 1 instead of a 100. So 1 minus 0.3 gives you a 0.7 chance that it does not happen. So even though we assume it's a 50-50 chance of having a boy versus a girl, in reality, in the U.S. there's usually more boys born. At one point, the statistic was that you had a 51.2% chance of having a boy. So the probability of having a boy was 0.512. These statistics are only referring to boy versus girl births, and they exclude some of those cases with ambiguous genders and things like that. So just among the clear genders, boy versus girl, about 51.2% are boys. So we're going to find the probability of not a boy. Well, 100% chance of one or the other. So 1 minus 0.512 chance of having a boy means the chance of not having a boy, or in this case having a girl, is 0.488. So let's look at another example, this time using the classical or theoretical approach. Let's say if someone is randomly selected, let's find the probability that his or her birthday is not in December. Okay, so we're going to find the probability of December and then find the complement. First thing we need to think about though is how are we going to count this? Are we going to count it as 1 month out of 12? Well, actually you have to be careful because when you're doing these, if you're breaking it up into months, you have to make sure that every simple event has the same chance of happening. But some months are longer than others. So you would have more of a chance of being born in December with 31 days than you would in February with 28. So we won't be able to break it up into months because they're not all the same size. So instead, we'll have to think of this as numbers of days. Let's assume this is a regular year with 365 days. So that means since December has 31 days, the probability of being born in December is 31 out of 365. So I'm going to do 1 minus 31 out of 365 to find the probability of not being born in December. So that's going to give us 0.915 or 91.5% chance of not being born in December. Another thing you could do is find the if you prefer to work with percentages instead of decimals, you could find the percentage for 31 out of 365, and then you could do 100% minus that if you prefer. Either way, you should come up with 91.5% chance.